So let's try and understand the asymmetric encryption using a very simple example again between Joy and Eileen. Now, when we studied symmetric encryption, there also Joy and Eileen were talking to each other and they were using the same key, right? What happens here is, if you see, Joy is having his own public key and secret key. So think of it as a private key, right? So wherever I'm talking about private, I'm actually saying secret key, right? So here Joy is having his own public key and private key, and Aileen is having her own public key and secret key. So as we studied, whenever we talk about asymmetric encryption, there will always be key pairs. But remember, these key pairs, now we are saying two people need to talk to each other. Both these people have their own set of public key, private key, public key, private key at the other end. If you see, and that's why I've used a different color coding. So here I have a different color and here I have a different color, which shows that they are different, right? They're not same, they're different keys. Okay, now let's start and try and understand. So Aileen this time tries to send a message hello to Joy, right? Now we know that Aileen shouldn't be sending the message as original text. What she would do? She would use Joy's public key and encrypt this message, right? Now you might ask, how does Aileen have Joy's public key? Yes, why not? Because Joy has distributed it freely to the entire world. So Aileen picks Joy's public key, encrypts the message, and what do you get? You get a ciphertext, right? So now we say that this is my ciphertext. Now by now we have studied that if you are taking original text, you are applying an encryption key or encryption algorithm, you get a ciphertext. What happens at the other end? Now what happens at the other end is Joy receives this message, right? Now I told you guys that if you are encrypting a message using a public key, then there is only one and only one key in the whole world that can decrypt this message, which is, any guesses? Yes, it is Joy's private key. So if now Joy applies this secret key, this one, onto the message, what will Joy get? You get hello, right? That is what all it shows, that you are encrypting using Joy's public key, but then when you have to decrypt, you have to decrypt using Joy's private key. And what does it give? It gives confidentiality. You now might remember the CIA triad we studied. So confidentiality, what it means is that the information that is being sent is confidential, which means if you are talking about privacy, because only Joy can actually decrypt this message, because nobody else in the world, any hacker in the world, won't be having Joy's secret key or the private key. That is why we say, if I'm exchanging confidential information, this is the mechanism I would be using. And this use case is a perfect use case for confidentiality or maintaining privacy. Why? Again, I'm telling you, because it was encrypted using Joy's public key, it has to be decrypted by Joy's private key. And the only person in the entire world who would be having Joy's secret key or Joy's private key is Joy himself. So thanks for watching, guys.